So we have a question here again, which has been asked in the CSIR-UGC-NET examination in the year 2022. So the question says that among the following, which set of molecular or ionic species all have a planar structure? And again, we will apply the VSEPR theory to solve this to get the geometry. So first we have BrF3. I hope the font and the question is quite clear because I have copied and pasted it from the question paper itself. I hope you can see it. So first one is BrF3. Now VSEPR theory says, first of all, what we have to do, we have to identify the central atom. And then we have to get the number of valence electron in the central atom. So bromine belonging to the halogen group, so it will have number of valence electron equal to 7. Now how many electrons are obtained from the bonded atoms? We have 3 fluorine atoms, so we will get 3 electrons from fluorine. So how many total number of electron pairs we have? We have to add up 7 plus 3, that gives us 10, and divided by 2, so we have 5 number of total electron pairs. Now identify the number of bond pairs. We have 3 fluorine bonded to bromine, so we have 3 bond pairs. Now what about the number of lone pairs? So total number of electron pairs is 5 minus bond pair is 3, so we have 2 lone pairs. Okay, so from the total number of electron pairs, we have the parent geometry as trigonal bipyramidal, TBP, according to the VSEPR theory. And then if we have lone pairs, this regular geometry is distorted. So we have 2 lone pairs, so the TBP geometry distorts to which shape? So this is how our actual TBP geometry looks like, but here we have 3 fluorine atoms. We accommodate it like this, 2 axial and 1 equatorial, and we are saving these 2 equatorial positions for the lone pairs. Okay, so we have already discussed in our previous videos that why we keep these lone pairs in the equatorial position, just to avoid the repulsion and to gain stability, because bond pair lone pair repulsion will be higher if we place them in the axial position. So this is how BrF3 looks like. And now what is this geometry known as? So this geometry is a T-shaped geometry, okay? Because it looks like the alphabet T. So here if we look it like this, then look at it like this, then this. Okay, so here is the central atom, then F, F and F. So it looks like the alphabet T. So it is T-shaped. Okay, so we do not have this structure. Now we have the next molecule, FClO2, where chlorine is the central atom. Because according to VSEPR, the atom which has lesser electronegativity, that is considered to be the central atom. And here chlorine is less electronegative than fluorine. So chlorine will be the central atom in FClO2. Now the number of valence electrons in Cl is 7. Number of electrons which is gained from other atoms, so from fluorine there is 1 fluorine atom, so 1, and from oxygen we will not consider whatever is gained from oxygen, because oxygen is double bonded here and VSEPR considers only the sigma bonded atoms. And then what is the total number of electron pairs? So we will add up 7 plus 1 from fluorine divided by 2, that is 8 by 2 is equal to 4 number of total electron pairs. Now what are the number of bonded pairs? So we have 1 fluorine and 2 oxygens. So in 2 oxygens, even if it is double bonded, there is 1 sigma bond in those double bonds. So we will consider fluorine 1 bond pair and 2 oxygens 1 bond pair. So total 3 bond pairs. Okay. So number of bond pairs is equal to 3. And then number of lone pairs. That is total number of electron pairs 4 minus number of bond pairs 3 is equal to 1. So we have 1 lone pairs. So according to VSEPR, for total number of electron pairs which is equal to 4, we have what kind of geometry? We have tetrahedral geometry. And this tetrahedral geometry distorts to pyramidal when we have 1 lone pair of electron, like we have in ammonia. So this compound becomes something like this. So double bonded oxygen, oxygen, fluorine, okay, and then a lone pair here on top. So this is a pyramidal structure. So FClO2 has a pyramidal structure. So this is also not a planar structure. Okay, then moving on to XeF5 minus. Now obviously the central atom is xenon here, okay. Now since xenon belongs to the 0 group, noble gases, or 8th group, so it contains 8 valence electrons. Then number of electrons gained from fluorine, so we have 5 fluorine atoms, so 5, and there is additional 1 negative charge also in this compound. Now the total number of electron pairs, so we have 8 plus 5 plus 1 by 2. That means we have 7 number of total electron pairs. And how many bond pairs we have? We have 5 bond pairs from 5 fluorine atoms. And then the number of lone pairs should be 7 minus 5, which is equal to 2 lone pairs. Now according to VSEPR, the total number of electron pairs, if it is 7, then it gives a regular geometry of pentagonal bipyramidal, which looks something like this. So we have an octahedral kind of structure and an additional bonded atom. So we have 7 bonded atoms here. So 3 plus 3, 6 and 1, 7. So basic structure is from octahedral and then an additional bonded atom. So that becomes the pentagonal bipyramidal. Now in this structure, if we have 2 lone pairs, then this structure gets distorted to, so we have 5 fluorine atoms and then we have 2 lone pairs, something like this. So it becomes some pentagonal kind of structure, and the lone pairs are somewhere in between, and actually the structure becomes like a pentagonal flat, and you can say that this structure is a planar structure. So actually the structure is pentagonal planar. So yes, XeF5 minus can be considered as a planar structure. As we have seen, after distortion from pentagonal bipyramidal, it becomes pentagonal planar with all the fluorine atoms oriented at the corners of a pentagon, 2-dimensional flat structure. So then let's move on to the next structure, what it was. So XeO3 also we have to check. So in xenon trioxide, XeO3, Xe is the central atom and the valence electron in xenon is 8, belonging to the 0 group, 8th group. And then it is bonded to how many? 3 oxygen atoms, and this could be doubly bonded. So this is ignored. So the number of electrons which is gained from oxygen is 0 because oxygen is doubly bonded, and VSEPR theory considers only the sigma bonds. Now total number of electron pairs. So we have only 8 divided by 2, that is equal to 4, and if this is the total number of electron pairs, then the regular geometry should be tetrahedral. Next comes the number of bond pairs. So how many bond pairs? So it is attached, xenon is attached to 3 oxygens, which even if they are doubly bonded, in that double bond there exists a sigma bond as well. So we will consider each oxygen contributes to one sigma bond. So we have number of bond pairs is equal to 3, and then how many lone pairs? So 4 minus 3 is equal to 1. And then from tetrahedral, because of this presence of the single lone pair, tetrahedral distorts to a pyramidal geometry, just like ammonia. So XeO3 has a structure something like this, okay, pyramidal structure. So this is also not planar. Then the next is ClF4 minus, okay. And then if we look carefully, the rest of the structures are the repeated ones which we already saw in the option 1 and 2. So last we will check ClF4 minus. Now in ClF4 minus, the central atom is chlorine. Okay, so the number of valence electrons in Cl is 7. Number of electrons which is gained from bonding with chlorine is 4, since we have 4 chlorine atoms, and then we have an additional negative charge. So total number of electron pairs becomes 7 plus 4 plus 1 negative charge by 2, that is 6. Okay, 6 total number of electron pairs. Now how many bond pairs? We have 4 chlorine atoms bonded, 4 fluorine atoms bonded to chlorine. So 4 bond pairs. Number of lone pairs 6 minus 4 is equal to 2 lone pairs. Now when we have total number of electron pairs is equal to 6, then the parent geometry or the regular geometry is octahedral according to VSEPR theory. Hybridization, you already know, sp3d2. So 3 plus 2 5 and 1 6. That gives rise to octahedral geometry. And now in this octahedral geometry, if there are 2 lone pairs, then this octahedral distorts to a square planar geometry. So ClF4 should look something like this, since it is square planar. So this is, yes, this is a planar structure. Okay, now let's go back to the question again. So in the first case BrF3 T-shaped, second case FClO2 is pyramidal, third case XeF5 minus is planar, that means one again planar we have, and what else? XeF5 is planar, then XeO3 is again pyramidal, non-planar. Then ClF4 minus is planar. So only 2 planar structures we discovered, XeF5 minus and ClF4 minus. Okay. Quickly, one thing I forgot to explain here, where should these lone pairs go? So these lone pairs, since it's octahedral basic geometry, so lone pairs are oriented somewhere like this. Okay, so basically it's a square planar geometry. Okay, now coming back to the question. So we have discovered only 2 species, XeF5 minus and ClF4 minus, to be planar. And that is the reason that in this question XeF5 minus and ClF4 minus. So this is minus, should not be confused. So might be a printing mistake. So this is XeF5 minus. So in this option 3, we have ClF4 minus and XeF5 minus together, which can be planar structures, but not BrF3, which is T-shaped. So actually we can consider T-shaped if two-dimensionally we observe that, then we can observe that this could also be planar, T-shaped planar structure. But actually this question does not contain those options which gives all the 3 species purely planar. Only option 3 contains 2 species, ClF4 minus and XeF5 minus, which are planar. And that is why in the answer key it is given that any of these can be correct. That means the question itself has some kind of error, incorrectness. That is why they have given the examination committee has given marks to anybody who has attempted this question. So the safest bet is when you are confused like this, if the options are not clear to you, then just the safest bet is where you think at least the 2 out of 3, at least the 2 are of the same structure, planar structure, then just tick that as the correct answer. So here we can safely say that option 3 could be the correct answer. Although the question contains some kind of error because there are none of the species in the 3 out of all these ionic species, none of the species are those which are there in the option where all of the 3 have the planar structure. So I hope this explanation and how the discrepancy of the question can be dealt with is clear to you, and hope it is helpful, and thank you so much.